Hey, Vsauce! Michael here. I am distorted. The pixels you are watching have been time displaced. They've been mapped onto a gradient, and the darker the region they're mapped to, the further behind they lag. The effect is really fun, but it's certainly not realistic. Or is it? Many popular digital cameras suffer from lag-induced distortion, like what you just saw, though much more subtle, usually completely unnoticeable. It's called a rolling shutter. Instead of snapping a full exposure at once, they quickly scan strips of each frame. It's usually undetectable, but when the subject changes faster than the camera scans, you get the famous jello-y, wobbly, rolling shutter effect. Really fast things like vibrating guitar strings and airplane propellers are famous victims, but people can be too. Luke Mandel submitted this photo to Boing Boing. His camera scans left to right, and in this instance, managed to capture a blink, eyes closed when the scan began, and then open in the reflection, scanned a fraction of a second later. But the rolling shutter effect is not just a neat curiosity. It represents a fundamental and inescapable distortion that affects everything we see, rolling shutter or not. First things first, let's talk about distortions. A hallucination is a distortion of reality when there is no apparent stimulus. If you are merely misinterpreting an actual stimulus, that is an illusion. But some distortions occur before our sense organs and minds get in the way. They are called optical phenomena. They are not the result of sensation or perception gone wrong. Instead, optical phenomena are distortions caused by the mere properties of light and matter in and of themselves. If you look up at the sky and see a giant, vivid drinking gourd, you are hallucinating. But if you see a flat, two-dimensional connect-the-dots Big Dipper, you are seeing an illusion. It's an illusion because those dots merely appear to be on the same plane, like holes poked in the dark roof of the sky. In reality, those dots are stars, light years apart from one another in 3 dimensions. As Celestia's brilliant free real-time 3D visualization of space shows, from different perspectives besides our own, they look a lot less like a dipper or plow. In fact, all constellations and asterisms are geocentric illusions. From a wider perspective, their outlines point inward to the single, lowly point in space that gave them their names. But you can't blame us. I mean, Earth is the only perspective any human has ever had. And even Voyager 1, the most distant man-made object, is still not even close to being far enough away for the constellations to look even remotely different than they do here on Earth. It's also not our fault, our eyes and brains' fault, that distant stars weren't included in our early Cosmic Connect the Dot game. Sure, our eyesight could be better, but optical phenomena are also to blame. If it weren't for redshifting and the inverse square law and light extinction, distant things could be seen in all their glory. The night sky would look phenomenal. Many structures up there are huge. That are just too dim for their hugeness to be appreciated. When we see Hubble telescope images of distant objects like the Helix Nebula, it's easy to think that without a telescope to zoom in, the object must just be a tiny point in the sky. But in reality, even though the Helix Nebula is 700 light-years away, it's 3 light-years across. If we could make the Helix Nebula less dim, if our eyes could take a really long exposure of it, we would see the Helix Nebula as it really is, nearly 70% the apparent diameter of our moon. This is a serious picture. That is how large the Helix Nebula would appear in the night sky from Earth if it just wasn't so dim. Our moon is tiny in the sky, by the way. It's easy to think of the moon as this huge baseball-sized thing up there in the sky, but that's an illusion. Try this the next time you see the moon. Grab a sheet of notebook paper, and you will notice that the angular diameter of the moon is the same size as a hole punched in a sheet of notebook paper held an arm's length away. Seriously, try it sometime. It shows just how cute and tiny our little moon is. The Orion Nebula would appear even larger if we saw all of its light, and the Andromeda Galaxy, just a smudge in the sky to our eyes, but if our eyes were better at collecting dim light, we would see Andromeda's true extent in our sky. Of course, our night sky doesn't look like that. Distant objects are dimmer. That's a bummer, but light still wins when it comes to speed. Light travels at the fastest speed, in fact. In a vacuum, light travels 300,000 kilometers a second. That's fast. But not really. I mean, not compared to how far apart things are in the universe. Sydney, Australia is 1/14th of a light second away from London. But the Andromeda Galaxy is 2.5 million light years away from London. To put that in perspective, let's take a light speed journey from London to Sydney. It would look like this. Ready? 3, 2, 1, go. Nice. All right. Here's the Andromeda Galaxy. Okay, now, relativistic effects aside, let's take a look at what it would look like to travel toward the Andromeda Galaxy at the speed of light. Are you ready? All right, 3, 2, 1, go! Yeah, I mean, seriously, it's pretty lame. Even at the speed of light, the fastest speed possible, a year from now, we won't even be a millionth of the way there. That's how far away Andromeda is. It's almost sad, in a way. But this brings us back to the rolling shutter effect. The Andromeda Galaxy is huge. It's more than 100,000 light years across, and our view of it is tilted, which means that on the plane we view it in, light from the back represents what Andromeda looked like thousands and thousands of years before what light from the front represents. Changes in its appearance reach us sooner from the front than from the back. Andromeda is rotating, spinning at hundreds of kilometers per second in some places. Now, a lag between light coming from near and far points on a spinning object results in a skewed image, the rolling shutter effect on a cosmic scale. Applied to, say, a chessboard, seeing the front ahead of the back is pretty trippy and dramatic. So, does that mean we see wobbly, funhouse mirror, rolling shutter effect versions of Andromeda and other distant galaxies? Well, technically, yeah. But the distortion is negligible. It may as well be ignored. Why? Well, the speeds used in these visualizations are not to scale. On average, yes, matter within galaxies orbits the galactic center at hundreds of kilometers per second, but galaxies are so huge, it takes them hundreds of millions of years to complete just one rotation. In other words, the lag between light reaching you from near and far points on a galaxy is nothing compared to how much time it takes matter in the galaxy to travel that same distance. In the case of Andromeda, if you insisted on seeing Andromeda as it really is, that is, corrected for any lag caused by the fact that the speed of light is finite, the most extreme points on the galaxy would only need to be adjusted by about a 10,000th of the width of any image. In this case, less than a pixel. So it's not a big deal. But it's not a nothing deal. It's real. In fact, everything we look at is in some way distorted by the fact that the speed of light is finite. Your own feet are about 5 to 6 light nanoseconds away from your eyes, which means when you look at your feet, you are seeing where they were 5 to 6 nanoseconds ago, 5 to 6 nanoseconds in the past. Of course, a delay that brief is pretty much undetectable, but it is calculatable. If it makes you feel a little sad to know that even with the sharpest mind or the best instruments, appearances still depend on where you are, that optical phenomena ensure appearances are always relative, don't feel bad. We call the people closest to us our relatives. We're really just a family. A big family of reference frames that, like a family, don't always agree, but do have plenty of cool things to look at. I'd like to thank my editor, Guy, for help with the rolling shutter effect in this video. And I'd like to thank you because, as always, thanks for watching. Oh, and here's something cool. I will be at YouTube FanFest with HP in India very, very soon. Check the description for more info. If you can make it, I hope to see you there.